Okay, so today we're going to go over lesson 4.5, which is writing the equations of parallel and perpendicular lines. So just a quick review of a couple of the formulas that we will be using. If you remember from an earlier lesson, we have point-slope form. And point-slope form is y minus y1 equals m times x minus x1. So that would be one that we will be using, as well as slope-intercept form. And that is just simply y equals mx plus b. Okay, so writing the equation of parallel and perpendicular lines. Now there's a couple important points here. So when we talk about parallel lines, we're talking about two lines that have the same slope. So if two non-vertical lines have the same slope, we would say that they are parallel. Just as if we see two lines that are parallel, then we know that they have the same slope. Now, as far as perpendicular lines are concerned, two lines in a plane are perpendicular if they intersect to form a right angle. And two non-vertical lines have slopes that are opposite reciprocals, then that means they're perpendicular. And the reverse is also true. If two lines are perpendicular, then we know their slopes have opposite reciprocals. So just to kind of give yourself the visual, we know that parallel lines would have the same slope. So if you look at an example like this here, this little sketch, notice, even though their slopes might be the same, they have different y-intercepts. So the line on the bottom, it looks like it's got a y-intercept of 0, or the origin, but the line that's parallel to it has a y-intercept of maybe positive 2. So we have to just be really careful with the fact that the y-intercepts are going to be different. If the y-intercept was also the same, it would really just be the same line. Now, as far as perpendicular lines are concerned, if I have one line and that's perpendicular to another line, and it's making that 90-degree angle, okay, notice that one of my lines is positive. In this case, this blue line would have a positive slope, and the other line would have to have a negative slope. There's no possible way for two lines to be perpendicular without having that different slope there, that negative and that positive. Now, if it's just any negative number and any positive number, they'll intersect, but it may not be perpendicular. They may not intersect to form that right angle. So in order to ensure that right angle, the slopes not only would have to be opposite signs, but also reciprocals of each other, because their rise over their run would be exactly the opposite. So if you had, for instance, a slope of, let's say, 3/4, rising 3 and running 4, then the other one would have to be the opposite. It would have to have a rise of 4 and a run of 3. So let's just take a look at how to identify these slopes of parallel lines and perpendicular lines. So if the original slope that you're given is 2/3, and you want to write the equation of the parallel line, okay, you're going to write the equation for the parallel line. Well, what slope are you going to use? Well, parallel lines have the same slope, so you would also use 2/3, positive 2/3, as your slope to write the equation of the parallel line. If the original slope, however, is 2/3 and you want to write the equation for the perpendicular line, well, now you have to do the opposite reciprocal slope. So if your original was positive 2/3, then yours is going to be negative 3/2. So let's take a look at the next one. If my original slope that's given to me is of a line that has a slope of negative 3/4, and I'm going to write the equation for a parallel line, then my slope will also be negative 3/4. There's no change. Exactly the same sign, the same numbers, everything. But if I want to write the equation for a line that's perpendicular, I need to change that sign from negative to positive, and I need to write the reciprocal, which would be 4/3. Now, when we take a look at the next example, our original slope that's given to us is simply just positive 5. So if I'm going to do the parallel line, of course, nothing changes. It stays exactly the same. I also have a positive 5 for my slope. But if I want to write the equation for a perpendicular line, I would have to change this slope. Now, obviously it would have to become negative because the original is positive, but this is really a 5 over 1. So when I write the reciprocal, it's going to be negative 1 over 5. Okay, next one, we have another integer here for my original slope of negative 2. Parallel line, of course, will be exactly the same. It will also be a negative 2. But if I'm going to write the equation for a perpendicular line, I'm going to have to make sure it's the opposite sign, which in this case would be positive, and then I have to write the reciprocal of 2, which would be 1 over 2. Now, if I have a 1, of course, the parallel line would also have a slope of 1 because it's going to have the same slope if they're parallel. But my perpendicular line this time is going to be negative 1. And the reason why is because this 1 is really over a 1, right? So I would have negative 1 over 1. But when you write the reciprocal of 1 over 1, it's still just the same thing. So it would just simplify to a negative 1. All right, let's take a look at the next one. Slope is 0. If I'm writing the equation for a parallel line, it would also have a slope of 0. But what is the perpendicular slope for a line that has the slope of 0? Well, if you remember, a slope of 0 is a horizontal line. So what would be the exact opposite of a horizontal line? Especially if you're thinking about drawing a line in the graph, it would have to be a vertical line. And if you remember that, slope would be undefined. So if you have a slope of 0 given to you and you need to write the equation of the line that's perpendicular to that, you know you're dealing with a line that's vertical and the slope is undefined. All right, so let's continue this, but this time let's get the information from an actual equation, since that's normally how it's going to look. So you have the equation of a line given to you. Clearly, our slope for this particular line is 1/2. It's whatever that number is in front of the x. Now, if I'm going to write the equation for a line that's parallel to this one, my slope is going to be also 1/2. However, if I'm going to write the equation here, it would be y equals 1/2 x, and then any other b value could work here. So if they don't give you the specific information, they just say write an equation of a line that's parallel to this one, I just can come up with any other b value, just not the +3, because if I write +3, then it's not a parallel line, it's the same line. Now perpendicular, the slope here would have to be negative 2 or negative 2 over 1. So if I were to write the equation, I would have to write negative 2x, and then I could put any y-intercept value that I'd like. So let's look at the next one. So I'm going to write the equation of a line that is parallel to this one. So I know my slope is going to be this negative 3/5, and then my equation will be y equals negative 3/5 x, and then I can put any b value that I'd like, just as long as it's not the same as this original one here, and that would work. If I want to write the equation of a perpendicular line, I first need to identify my slope by writing the opposite reciprocal of the one that's given. So the opposite reciprocal of negative 3/5 would be positive 5/3. So now when I write the equation, I'm going to have 5/3 x, and then I can put any y-intercept value that I'd like there. Okay, now the next one, the equation here has a slope of 4. So if I'm going to write the equation for a parallel line, it's also going to have a slope of 4, but it's going to have a different y-intercept than this here. And if I'm going to write the equation of a line that's perpendicular to this one, my slope would have to be negative 1/4 because that's the opposite reciprocal. And then my equation would be y equals negative 1/4 x, and then I could put any y-intercept value that I want here. Okay, and then the last one, again, if I'm writing the equation of a line that is parallel to this one, it will also have a slope of -6, but it would have a different y-intercept. So I'm just going to leave that blank, indicating it would be a y-intercept of 0. My perpendicular line, of course, would have to be the opposite reciprocal, which would give me a positive 1/6. So the equation of the perpendicular line would be 1/6 x, and then I could have any y-intercept that I wanted on the end. Okay, so now I'm going to give you an example where we're going to write the equation of the parallel line, just like we did in that chart. However, it's going to tell us specifically it's going through this point. So we can't just make up any y-intercept this time. We have to be specific and find the exact parallel line that's going to go through this point here. So our first step, of course, is to identify the slope, which we just kind of went over on the last page. Now, this is the original line that's given to us. Obviously, we can see the slope here is -1, right? But because our line is going to be parallel, it's also going to have a slope of -1. Now, the second step is going to be to either find the y-intercept, which is that b value, or use point slope form, because our end result that we're looking for is going to be putting it in the y equals mx plus b equation, and we can use either of these methods to get there. So I'm going to say this is option 1, and I'll say this is option 2, and I'll show you how you could do it either way. So if you're going to do option 1, and that's find the b value, right? You're going to use the point that's given to you, and that's going to go in for your y and your x, and of course your slope. And we're really just plugging into that slope-intercept form, right? So 6 equals -1 times 2 plus b, and then we're just going to simplify this here, and then we're going to get the b by itself, and we end up with a b value of 8. Now, of course, once you do that, you now have your slope. You also have your y-intercept, so you can write your equation y equals -1x plus 8. Notice it has the same slope as the original equation that was given to you, but it has a different y-intercept. It's a +8 versus the +2. Okay, now the other option is to, instead of finding the b, just using point slope form to get to your y equals mx plus b. So in that case, again, we're still using the same point here. It's just going to be x1, y1. So y minus 6 equals my slope times x minus 2. And then I can distribute that slope. So I have -1x plus 2, and then simply bring this number over to the other side, combining it with the like term, and I have y equals -x plus 8 as my final answer for that parallel line equation. Okay, so finding the slope and then using whichever method you like to use to get to that end result of slope-intercept form. Now, if you use option 2, you can still identify that that y-intercept is 8, and then, of course, your slope is still -1. All right, so let's try these two examples. Again, we're focusing on parallel lines here, which have the same slope as the equation that's originally given to you. So in number 1 here, we know that this slope here in this original equation is 2/3. And since I'm writing the equation of a line that's parallel, my slope will also be 2/3. So now for the second part, I'm going to either find b or use point slope form. So I'm going to find b for number 1, and then I'll do the other method for number 2. So if I'm finding b, I'm using the slope-intercept form, and I'm going to use 9 for my x and 2 for my y. So 2 equals 2/3 times 9 plus b. When I multiply here, I end up with 6 plus b. And of course, then I would get my b by itself by subtracting the 6. And that gives me -4. And now I can write my equation in slope-intercept form. Y equals 2/3 x minus 4. So notice it has the same slope as my original equation, but a different y-intercept. Okay, so taking a look at number 2, same concept here. So we have this original equation given to us, and they want us to write an equation of a line that's parallel to this and goes through the point -3, -4. So since they're parallel, according to the directions, I know that my slope has to be the same as this equation, and it's also going to be that -2. Now this time, in order for me to get to that equation, instead of finding the b, I'm just going to plug into point slope form, just as a different option. And remember, point slope is y minus y1 equals m times x minus x1. Now, because my x1 and my y1 are both negatives, when I subtract those negatives, it's going to have to change to a positive, just to keep that in mind. So when I'm subtracting that -4, it's really y plus 4. And then over here, subtracting that -3 is really a plus 3. And now to get it into my slope-intercept, I'm just going to get rid of those parentheses by distributing the slope and then subtracting that 4. So I end up with y equals -2x minus 10. Now, once again, you can see same slope, -2, because they're parallel, different y-intercepts. And again, if you chose to use point slope for number 1 or find the b for number 2, you should still have gotten the same final equation. All right, so in example 2, we're going to determine whether lines are parallel or perpendicular. So we're really just going to have to identify the slopes of each of these 3 lines and then look at and see if they have anything in common, or do they have opposite signs, are they reciprocals, are they the same? So if we take a look at line A, in order to find the slope, I'm going to need to have it in slope-intercept form. So once you have it in slope-intercept form, you can identify that slope. So this first problem, obviously I need to get the y by itself. So I'm going to subtract 4x from each side. That leaves me with -6y equals -4x minus 8. Then I'm going to divide everything by that -6. So I now have y equals positive 2/3 x, because -4 over -6 simplifies to 2/3, and -8 over -6 simplifies to 4 over 3. So now that I have my equation in slope-intercept form, I can see that my slope is positive 2/3. Now remember, your slope is not the x, it's just the number in front of the x. All right, let's look at line B. Now line B is already in slope-intercept form, so I can just pick out my slope here, which is positive 2/3. And then if we're going to go to line C, again, I have to get the y by itself, so I'm going to move my x term over to the other side. 3y equals -2x minus 15. Divide everything by 3. Y equals -2/3 x minus 5. And then this one, I can see that my slope is -2/3. Okay, so is there any relationship between these 3 lines here? So if we look at the first 2, right, this one and this one are the same. So we know that line A is parallel to line B because they are the same slope. So because they have the same slope of positive 2/3. Now, even though line C is 2/3, it's a -2/3, so it's definitely not parallel to either A or B, but it's also not perpendicular because it's not flipped. It's still written with the 2 on the top and the 3 on the bottom. Now, if it was -3/2, then it would be perpendicular to the others. So right now, it doesn't have any special relationship with either line A or line B. So now if we look at the next example, same idea. All All right, so line A, I'm going to get my y by itself. So we're going to add 3x. So I have negative 12y equals 3x plus 36. And I'm going to divide everything by negative 12. Y equals negative 1/4 x when I simplify that, minus 3. So my slope here is negative 1/4. And I see that right in front there. Okay, so now I'm going to go to line B. Again, I need to get the x or the y by itself. So 4y equals negative x plus 2, and then I'm dividing everything by 4. Now remember, when there's no number there, it's really a 1, so this is negative 1/4 x plus 1/2. And again, my slope is that number in front of the x, so that's negative 1/4 right here. And then the third one, line C, we already can see the number. It's already in slope-intercept form, so we know our slope is 4, or it might be helpful to write it as 4/1. Okay, so now let's look at the relationship between these lines. So we, again, just like the last problem, we can see that line A is parallel to line B because they have the same exact slope. They're both negative, and both have a 1 on the top and a 4 on the bottom. But when we look at line C, we can see that line C is perpendicular to both line A, and line C is also perpendicular to line B. Okay, and if you think about, line C is positive 4/1, whereas A and B are both negative 1/4. So we can see that one is positive and has 4 on top, 1 on the bottom, and the other one is the opposite sign because it's negative and it's the reciprocal. Okay, so hopefully you have a better understanding of how those perpendicular slopes work, and now we can write the equation of a perpendicular line. Okay, so the steps are still the same as what we did with the parallel lines, but obviously our slope's going to be a little bit different now. So again, writing the equation of a line passing through a specific point here that's given to us, and it's perpendicular to this line here given by this equation. So we can see that the slope of this particular line that's given to us is negative 1/3. So what would be the slope of the perpendicular line that we want to write the equation for? Well, we would have to change that sign to positive and write the reciprocal. And then that, of course, would simplify to 3. So that's the slope that we're going to have to use to write the equation of the perpendicular line. Now, since it's going to go through this specific point here, negative 2, 1, again, you have two options for how you want to continue this problem. So you can find the y-intercept, or you can use point slope, either one. So if you were to use the y-intercept, right, and you're going to plug it into y equals mx plus b, that's kind of like option 1, right? You're going to plug in your 1 for the y equals your slope times your x plus b, and then you get your negative 6 and you add it to the other side and you have your b, and then now you can write your equation y equals 3x plus 7. Totally fine to do it that way. Okay, if you rather do point slope, y minus y1 equals m times x minus x1. Now this is just an x1 and a y1. So y minus 1 equals 3 times x. Remember, when you subtract that negative 2, it becomes a plus 2. And now we're just going to distribute. So we get 3x plus 6. Add the 1 to the other side. So now we get the equation y equals 3x plus 7. And we can clearly see that y-intercept is positive 7. Okay, so writing the equation of a line that passes through the point 5, 3, and it's perpendicular to this line here. So again, first thing we want to do, find the slope. Now we can see that this slope here is a -5, but we want to write the equation of a line perpendicular to the -5. So our slope is going to be positive 1/5. Then for the second step, we can find the b. So if we find b, we're plugging into y equals mx plus b, and we're using the point given to us. So 3 equals 1/5 times 5 plus b. And then, of course, we would get the b by itself. So b would equal 2. And then we could just simply write our equation, y equals 1/5 x plus 2. Of course, that's not the only option. If you would rather do point slope instead, that's your y minus y1 equals m times x minus x1. Then I would have y minus 3 equals 1/5 times x minus 5. Then I would do my distributing, 1/5 x minus 1, and then bring that 3 to the other side, which gets me that y-intercept of 2. And again, same answer, just a different option of how to get there. And that's how you write the equation of parallel and perpendicular lines.